Kia ora koutou. This is a really quick video for Mingston on question 12 in exercise 3C. So question 12 is kind of a classic Cambridge question. It has to be done using no calculator, and we're told that we've got cos of A is equal to 3/5 and that angle A is in the first quadrant. So what that means is that we can straight away, if we've got that, we know we've got an acute angle. So we can draw ourselves a triangle and write on cos of A. So A is equal to, so using so katoa, here's angle A, and cos of A is 3/5. So the adjacent angle is 3 and the hypotenuse is 5. Now that means, and Mingston, I reckon you're probably sitting there going, oh, why did I not realize that it was this in this question? We can just use Pythagoras, right, to get this side here. And we know that we've got a 3, 4, 5 triangle, right? But if we were doing a one with harder numbers, you'd use Pythagoras there. That means that we know sine and cos and tan of angle A. So to find the exact value of sine of A minus 30, we'll use our compound angles. So sine of A minus 30 degrees is sine A cos of 30 degrees minus cos A sine of 30 degrees. And we'll just whack in our special triangle there with those values on it. It's a terrible special triangle, but hey. Okay, so sine of A is equal to 4/5, right, opposite, over hypotenuse, times cosine of 30 degrees, which is root 3/2, minus cos of A, 3/5, times 1/2. And that's all there is to it. So that's worth, so that's 4 root 3 minus 3 divided by 10. Now that's the first part of the question. Next, we have to find the exact value of tan of 2a, and then we have to find tan of 3a. But because we've got our 3, 4, 5 triangle, again, this is pretty straightforward using our compound and double angular angle formulae. So tan of 2a is equal to 2 tan a over 1 minus tan squared a. That's given to you, it's definitely given to you on the level 3 formula sheet, but it's just an application of tan of A plus B, where instead of B, we've got a second A, right? So that's double angle for tan. So let's look at our 3, 4, 5 triangle. We've got A is here, so the opposite is 4, and the adjacent is 3. So it will be 2 times 4/3 over 1 minus 4/3 squared, which gives me 8 over 3 divided by, the denominator will give me something over 9, so it'll be 9 minus 16, which equals 8/3 times 9 over negative 7. These simplify, and that gives me negative 24 over 7. Okay, so that's tan of 2a. Lastly, we have to find tan of 3a. So tan of 3a we can get as tan of 2a plus a. Now we're going to use our compound angle formula. So we've got tan of 2a plus tan of a divided by 1 minus tan 2a tan a. That gives me what? Well, we've got negative 24 over 7 from what we just did, plus tan of a, which is 4/3. I bet you've all turned the video off by now, but that's okay, as long as you get to the end nicely. Cleaning that up, what do I get? Well, common denominator for this is 21. 24 3s are 72, so negative 72 plus 4 7s are 28. Got that divided by 21 plus 96 over 21, which gives me not a particularly nice number, negative 44 over 21. I'm sorry, there's a mistake there. That should be divided by there. And now it's going to be times 21 over 117, giving us a final answer of negative 44 over 117. So, Mingston, I hope that helps. This is a kind of classic Cambridge thing to check that you really understand what it means to be working in the first quadrant. It means that we can always go and get the third side of a triangle, and that's a really useful thing to do because it means that I can identify any of the 6 trig ratios, and then I can use those in harder problems. Thanks for watching, guys, and I'm about to do one for Ben, which is a little bit the same, but a little bit harder, from exercise 3B. Okay.